Welcome folks, in this video we're going to talk about motion in the night sky, what we call celestial motion, that theatrical dance in the sky that had our ancestors bewildered and caused them to make up lots of stories and reasons why certain things happened. For example, the ancient Chinese astronomers envisaged a huge dragon coming in and consuming the sun at various points that the sun disappeared in the past. If we look at the Egyptians, they had a theory on it where a serpent, a peep, used to come in and attack the sun god Ra. And if we go over to a little bit northwest of that, in Norse mythology, the sky wolves Hati and Skull used to chase, in mythology, chase the sun and the moon around and cause them to disappear at various times. We're going to just have a look at some of those motions in the night sky, some of the terminology, vocabularies, and the reasons for that celestial motion. Two motion concepts that we're going to talk about that sound very similar to each other are the concepts of rotation and revolution. So if we just begin with rotation, rotation is the motion of the Earth spinning around its own axis. So it's, if you could consider the Earth, if you can imagine it on a stick, a pogo stick or something like that, and the Earth is spinning around its own axis. That is what we refer to as rotation. And of course, maybe you can stop the video and think about how long each of those rotation takes. And if you said 24 hours, you'd be correct. It's the rotation that gives us our feeling and sense of days. We have a spinning GIF here just to show you what that rotation might look like. The rotation is, you'll also notice that the rotation is slightly tilted. So we're just going to have a look at that and what that means a little bit later on. But it is important to, at this point, note that it's a tilted rotation. It's tilted at about 23.45 from that straight, from that vertical. And that essentially is what gives us our seasons. So somebody in the northern hemisphere at this time of year will be further away from the sun than somebody in the southern hemisphere at that time of year. So that is what rotation means. If we now go and have a look at revolution, the revolution is the orbiting of the Earth or any body around a larger body. So if we were to look at this PhET simulation, gravity and orbits, which I'm not going to run right now, but I would highly recommend, we can see that the Earth here would orbit the sun. Hopefully we know enough to know that at this stage that this would take approximately 365.25 days. I'll let you maybe have a think about why, or what's the significance of the 0.25 there. But for different bodies it would take different times. So for example, for the moon to orbit the Earth, that revolution would take approximately just under 28 days. So there is a big difference, and the revolution, of course, gives us our sense of years, not days, so 365. So putting all that together, we can look at this model of the Earth orbiting the sun. We'll see that they're on tilted axis, and what does that mean for a person, let's say, in the summertime, who is in Asia, let's say the Middle East right there, as distinct from somebody who's in Madagascar? Well, if we look at the relative distances to the sun, we'll see that the northern hemisphere in the summertime in June is closer than the southern hemisphere. And this is why there's this perception and this feeling of summertime, because the temperatures are higher, because they're facing the sun. Similarly, if we look at the other time of year, somebody in, let's say, Toronto in Canada against somebody in Australia, the people in Australia are closer to the sun than the people in Canada. And so this would give the winter season in the northern hemisphere and the summer season in the southern hemisphere. Now back to those beliefs of the Norse people and Hati and Skoll and Apip. What they were trying to make sense of is this beautiful phenomenon that we see from time to time, which we call eclipses. And eclipse actually comes from the Greek word to disappear. The Greeks were very upset that there was a disappearance that happened, and they used to think that it foretold very bad things happening. So a solar eclipse, what's the difference between solar and lunar eclipse? Well, when we have a look at our solar eclipse here, we see that basically the moon gets in between the earth and the sun. One thing that I probably should say is that the moon should be much, much closer to the earth. However, the moon is blocking those rays that are coming from the sun towards earth. They're being blocked by the moon, and so there would be that shade here in the middle of the day. So that is a solar eclipse. Solar eclipses are always occur during the day where they're seen. A total solar eclipse happens once every 2 years somewhere on Earth. That's a total full solar eclipse, but they're much rarer than that if you happen to be in one part of the Earth. You can wait a long time, hundreds of years for them to happen, and the temperature can drop about 20 degrees. Now, when you look at a solar eclipse in its totality, when it's fully covered by the moon, the sun is fully covered, we can see it's one of the rare times, one of the only times we can see the sun's corona, which is a word that's on everybody's lips right now. And corona means crown, I believe, in Spanish. And this corona here is the outside that we're seeing during this solar eclipse. So if we compare that to a lunar eclipse meaning eclipse of the moon, of course, we can see that in this one, the moon is always rotating around the earth, and instead of blocking the sun's light, and instead of the moon being over at this point here and being a huge reflector of light from the sun, it's essentially a big mirror. The moon doesn't make its own light. Instead of that being the case, it is blocked by the earth. So the sun's light cannot now bounce off the moon. Instead, the moon goes dark because there's no light able to go and bounce off of the moon. And so this is what we call a lunar eclipse. And what are some things that we see in a lunar eclipse? Well, lunar eclipses of course, would occur at nighttime. They're much, much more common than solar eclipses. And a total eclipse can last for a long time. A solar eclipse can last up to about 7 minutes, but a lunar eclipse can be over an hour in terms of time frame. And if we look at just some of the camera images that would be captured from a lunar eclipse, you can see that at its totality here, we have this image here, which some people like to call a blood moon. And the moon can take on many different colors. So that's some of the differences between a solar eclipse and a lunar eclipse. So what does this all mean for us as we look up into the night sky, which hopefully you will go out and do tonight? We see some beautiful, amazing things that come into our view in the night sky. And that's caused by the rotations and revolutions that we talked about. And this person right here will see stars and constellations sweeping across, and that is because of something called a horizon. Those stars will appear to move east to west, just like our closest star, Solaris, the sun. And when we look up into that sky, we may see some really, really cool constellations. If we're lucky enough in the springtime, we may see the constellation that's pictured right here, which is Libra, which is also a horoscope sign, and that will move across the night sky. We also might see at a different time of year, in the summertime, we might see this constellation down here that we call the Little Dipper. the Little Dipper. Now the Little Dipper is an interesting constellation because right at its tail it has an interesting star which is called Polaris. We also call it the North Star. And that's a really great star to try and look at. It's very visible. And one of the things you'll notice in the summertime in the northern hemisphere is that it does not move while all the rest of the stars are appearing to move. Polaris is not moving as much, and one of the reasons is it's based directly above the North Pole. So even though Earth is spinning, the North Pole isn't spinning as much. So there's some of the constellations that you might be able to see depending on the time of year. If you're in the southern hemisphere, you're going to see a whole different collection of wonderful shining stars that will light up your nighttime, hopefully. So that is just some of the types of motion that happens in the night sky. Please go out, have a look up, and wonder about those things above you. And also don't forget to give me a wee thumbs up if you like this video.